This is the brief on tensor basis transformations. When you're tackling tricky physics problems, especially stuff that rotates, a single fixed coordinate system just doesn't cut it. You need some powerful math to switch between them. And that's where tensors come in. They're basically the tool we use to see how things change when our point of view is on the move. First, it all starts with the physical rotation. Think about your standard XY grid. Those directions are locked in, right? But with polar coordinates, the basis vectors actually point in different directions as you swing around a circle. And that physical change, that movement, is exactly why we need to do all this transformation math in the first place. Second, since our physical vectors are moving, we need a mathematical tool that can keep up. So we build what's called a tensor basis. We create it using a special operation called the outer product of the vectors, which gives us the exact algebraic structure to describe that rotation. And finally, the whole point is to connect this new, rotating tensor basis back to our original familiar Cartesian system. This step is the crucial link. It lets us do all our fancy calculations in the rotating system, but then translate the answer back to a fixed frame we can actually make sense of. So remember, when your physical vectors change direction, you absolutely need an algebraic map to follow them and keep the math straight.